Okay, I had to retrace the graph basically. It's quite some more to have a smoother curve along this, especially the area around the point where you should find the gradient. Okay, so let me see the line I'm able to get now. So remember, the tangent should only touch the curve at one point, right? And so you try to draw a straight line that touches it only at one point. Right? So we have, this is the best we can do. So we have this point. So let's try and pick these numbers up. So we have a point here and a point here. Now, so let's try and draw a triangle joining the points. Oops, this does not look very pretty. Sorry guys, this is really difficult with the tablet. Okay. Now, so we have, so this here, what we have here are the first set of points. You can imagine we said this is 0. Going forwards are positive numbers. Going here are negative. Here, negative, here, positive. So as you go this end, the numbers increase. As you go this end, the numbers increase. So we have basically the points of x. We have an x value here. And we have another, as we go this way, we have another x value, right? So we call this x1 and this one x2. While here, from this point we have here a point y, we can call this point here, this point y1. But as we climb up, what we have is, as we come to this other point here, climbing up, basically we are moving from this point and climbing all the way to this point here. So we have the point for y as 0 because this is the y-axis, remember. So it is, the point is lying on y equal to 0 here. Okay, so we call that y2. So we call this, so we have x2 and y2. Remember, this is the value of x and this is the value of y. So we have x2, y2. Okay, so just as we had here, y is growing from here at y1 to as we go up to y2. Right? Now, what we can do easily is to pick up these numbers, what these numbers represent, and try to find our gradient. So the gradient, we can say Roman 3. The gradient at the point x equal 2, so basically, which means the rate at which the curve is changing, the function is changing with respect to x, with the values of x at the point 2. We want to find the exact rate of change. Okay, so this will be equal to m, which is y2 minus y1. So the change in y divided by, let's make that a better line, divided by the change in x. So x2 minus x1. Okay, higher y minus lower y gives us the change. So we're basically subtracting the two values and then seeing what the difference is. That difference is the change. So this is equal to, now we have, sorry, just checking that. So we have y2 is here, right? So, but here it is 0. So this is 0 minus y1. What is y1? Y1 is here. Sorry, all these numbers here are negative. I forgot that. God. So all these numbers below 0 are negative for the y, and here also for the x are negative. Here positive, here positive. Right. Now, so we have 0 minus y1, which is minus 10 at this point. Here, minus 10 divided by x2 here at this point. We have here x is 2 here and then here 2.5, so we can count the boxes 2.6 to 2.7, 2.8. okay, so we have 2.8 minus x1. x1 is around, so here x1 we have here, this point here is 1. okay, so we move 1.1, 1.2 minus 1.2. okay, so now let's give us some more space. So we say, so this will be equal to, remember, it is good putting this in brackets here when you are dealing with negative numbers, so you don't mess them up. So minus times minus is plus, right? So 0 plus 10 divided by 2.8 minus 1.2. So 2 minus 1 is 1, 8 minus 2 is 6. So this is 1.6, right? So this will be equal to 10 divided by 1.6. So we can say therefore the gradient, which is m, is equal to 10 divided by 1.6 gives us 6.25. 6.25. okay, so this is the gradient of the curve at the point x equal to 2.